Thank you so much for joining us. It's a real honor to welcome you to AstroTeach. For our audience, today we are honored to be speaking with a true pioneer, Dr. Rosaly Lopes, a planetary geologist at NASA's Jet Propulsion Laboratory and a Guinness World Record holder and a passionate science communicator. Thank you so much for joining us, Dr. Lopes.
I was born in Rio de Janeiro, Brazil, and I grew up in a family where there weren't any scientists. But I became very passionate about space exploration. I grew up hearing about the Apollo program and the race to the moon, and I really wanted to be an astronaut. But then I realized I was Brazilian, female, and with terrible eyesight. So I realized I wasn't quite going to make it, at least back then. Uh, and so I decided to become an astronomer and to help NASA explore space and the solar system. And I really wanted to work for NASA. Then I luckily, my parents taught me English from a young age, and I eventually got a place at the University of London, at University College London, to study astronomy. And in my last year studying astronomy, I had a class in planetary geology, and the professor was a volcanologist. And about, I don't know, a few weeks into the course, one day the professor didn't show up. And this postdoc showed up and he said, "Oh, Mount Etna, a volcano in Sicily, erupted, and the professor had to go." And I thought that was really exciting. I always had an adventurer streak. And I thought that sounds really exciting. And I really enjoyed that class. So I, later went to talk to him and I said, I really want to do a PhD and I would like to do a PhD in planetary geology. And luckily he accepted me. So that's how it all went. Well, the first time I went to a volcano was still my first year of PhD, because my professor said, you can't study volcanoes on other planets if you don't understand them on Earth. So he took me to help field work on Mount Etna. And while we were there, Mount Etna erupted. And it was just beautiful. It has what we call strombolian activity, which is not particularly dangerous, but it has these small explosions that send lava fragments into the air, and it's like fireworks. And I was totally hooked. So I became totally hooked on active volcanoes. And eventually I came to JPL as a postdoc. And worked. I worked first on volcanoes on Mars, and then got a position on the Galileo mission that went to Jupiter and studied volcanoes on Io, and so on. Well, before the Galileo mission, we knew of about a dozen active volcanoes on Io. And I worked on Galileo with the near-infrared mapping spectrometer that can detect heat from the volcanoes. And I remember a colleague asking, "Do you think you're going to find a new active volcano on Io?" We call them hotspots. And I said, if I'm very lucky. And right away, on the first observation, we found like 4 or 5. And we did that. Essentially, we detected the heat in the pixels, and I started doing that, just comparing the observations pixel by pixel, and identifying these active volcanoes. And by the end of the mission, I had found 71. In 2006, I got a small mention in the Guinness Book of World Records as the discoverer of the most active volcanoes anywhere. So that was very cool. On Earth, we have very few impact craters compared to, for example, the moon, because the Earth had a lot of erosion and plate tectonics. So those old craters that were formed back when the solar system had a lot more impactors, a lot more impacts on Earth have been erased. But on the moon, we still have many. And in fact, the moon really helped us understand how often impacts can happen. I think that returning samples from other worlds is really the most exciting, let's say, new development. And we have had, samples back from asteroids, for example. And you can't send on a spacecraft the same kind of instrumentation that we have on labs on Earth. So that's why we're really trying to bring back rocks from Mars because we can really analyze them on Earth and answer questions like, were there signs of life on those rocks on Mars?
You didn't just write a textbook, you wrote the Volcano Adventure Guide. What's one piece of advice from that book that you know has actually helped keep someone safe? And could you also tell us briefly about your other books?
Oh, sure. I I have written quite a few books, and but the Volcano Adventure Guide, I think, remains my favorite. I wrote it for a general audience. I wrote it because I give talks about volcanoes, and I often get asked, how can I visit a volcano? How can I photograph a volcano? Um, what is dangerous and what's not dangerous? So I thought no one has written a book about that, really telling people that, yes, there are volcanoes that you can visit, and you can visit quite safely if you know what you're doing. And I think our best chance of finding if there was life elsewhere is to bring back the rocks from Mars that were collected by the Perseverance rover. And some of those, results were published recently, really show signs that uh, uh, there could have been life there, similar chemistry and even morphology of some spots that you find on ancient rocks on Earth. I would say that one of my proudest moments was when I was awarded the American Astronomical Society's Division for Planetary Sciences Carl Sagan Medal in 2005. And the medal is given to a planetary scientist who is active in research, but who also does public outreach. And I think that was really very, very special. Oh, there are so many. I have this special interest on Io, uh, and although I have researched, other bodies, but I think Io is my particular interest, and I'd really like to know what Io's lavas are made of, and how Io ended up so different from Europa, Ganymede, and Callisto, other Galilean satellites. And I'm at the moment studying or helping to study possible Io sample return mission that would not only tell us that, but it could tell us so much about the formation of the solar system, because we have no samples from the outer solar system. So that would be really amazing.
Mhm. What's the most memorable moment you've had in your scientific career?
I think actually seeing the surface of Titan for the first time with radar, which was totally unknown, that was really an amazing moment. And every time we had a new flyby and we got with a synthetic aperture radar during the flyby, you get like a long strip that shows you actually a small part of the moon, and 1 to 2% of the surface. And every time it was really a thrill. And when we found the lakes of methane and ethane close to the North Pole, in the North Polar regions, that was amazing. We were looking for them. We thought the lakes were there, and finally we got them.
Yeah.
Well, I really love talking to younger people and students, and encouraging everyone to pursue their dreams. When I was a kid, there had never been a scientist in my family, let alone a female, and um, and people used to laugh and think it was so cute that this little Brazilian girl wanted to study astronomy and work for NASA, but I managed to do it. So it takes commitment. People can do amazing things if they put the commitment and the work and the discipline in it. And also never measure success by where exactly you are, but I measure success by how far you have come. So I think that I have come a long way, and I hope that you all do too.